Welcome back to the Logic video series. This time we're going to talk about compressing truth tables. Once in a while, this is a useful process to know. And the idea basically is that we want to reduce the number of input variables that show up in truth tables on the input section of the truth table. Obviously, we can't get rid of them completely. What they happens, instead of having zeros and ones for the output, we would have expressions that describe the output. So that's the big change that happens there. So let's go ahead and take a look at that. It's a relatively straightforward process. Let's say someone asks us to compress a truth table, the truth table around a variable. Let's say we have a function that giving a function to us which has three variables, a, b, and c, and then they're asking us to compress the truth table around, sometimes called around, sometimes called with respect to whatever of c. So by that basically are telling us that the goal is not to have c be in the input side for defining this, whatever this function a, b, and c is. Let's say someone gave us a table like this, and let's go ahead and fill it in so we have a good starting place, and asked us to compress it. So let's go ahead and fill it in with normally what we do. And 1, 1, 1. Great. And let's say in this one we have 0, 0, 1, 1, 0, 1, 1, 0. Let's say that's a function is given to us. We don't know what this function is. We're not even interested at this point. We're only interested in, is there a way we could compress this table so we could have a compressed around C table that would in it have only A and B on the input side, and then we could have a function that is compressed, still is a, the function still is a variable of A, B, C, but our truth table will only have 4 rows. All right, so this one is very nice because C is the least significant bit the word they're giving us, and I'll use a different color so it's so easier. So C is what we want to compress around it, and they'll be nice enough to give it to us as a single, as the least significant bit. So what all we have to do is group them such that each group has A and B the same, but C changing. So our 8 rows, if it was 16, whatever the case is, it would divide in half. So in this particular case, we would have a 4 rows here. Row 0, 1, 2, and 3. Each of these rows represent 2 of the rows here. Okay. Now the question is, what do I put in here? I can't put a 0, or maybe I can put a 0. In this case, when we look at this, we look at these two and say, okay, A and B are 0, so we're looking at right here. C can be 0 and 1. We don't have it here, so we don't know what it is. But we really don't care because the output is always 0. So that was easy. Then we go to the next one. We say, okay, in this case, 0s and 1s are changing, but A, B are 0, 1. So that's this row. So the question is, what do I do with F? Oh, F is simply 1. Done. And then we go to the next one. Okay, it's 1, 0, 1, 0. AB is 1, 0. But how about C? C is changing. Okay, can I just write 0 and 1? In this case, I can't, because you can see if C is 0, it is 0. If C is 1, it is 1. Oh, so that would be just simply a C. Now we get down here, same thing. We'll group these two together. Look at it, say, function is not 0 or 1, so I can't really write 0 and 1 there. But I see as C is 0, function is 1, as C is 1, function is 0. All right, so that's got to be C naught. There we go. What we do, we took the original function, we compressed the original function such that now we only have 4 rows, or just 2 inputs. and the function is still the same function. So if you start plugging values in it, you're going to get exactly the same f for every possible values of a, b, and c. So we didn't change the function, we just compressed it around c. Let's say after you finish with this, then they come and ask you, can you go ahead and compress it around b also? And the answer is yes, I compress around b. So the answer is yes, we could do this. All we have to do the same thing we did over there. Group them in groups of 2. And then our new compressed table only going to have a on the input side. And still we're representing the same function. So better the values better not change for a combination of a, b, and c. So in this case, we're only going to have 0 and 1. So 0 represent the upper 2. So in this case, b can be 0 and 1. And if b is 0 and 1, this is 0 and 1, which means this is simply a b. Okay. And then how about 1? 1 is a little trickier. The simplest way is to look at c, say, okay, I'll put it c when it's 0. So I'm going to just simply say that. Say, if b is 0, then whatever value c has controls everything. Now, or, does that takes care of the upper part? How about the lower part? Lower part says when b is true, b is 1, then c not control it. Okay. One thing you got to realize, this approach doesn't, if you continue this approach to the next step, you will have one expression. So let's go do that. You can continue, although you rarely do this, but somebody could come along and say, okay, you compressed it around a, compressed it around b, let's go to compress it around c as well. So this is compressing it around a, b, and c. So we're going to compress it around, or with respect to sometime c. I'm sorry, a in this case. So if I do this, really is not meaningful to have a truth table because there is no variable on the input side. It's completely empty. So all we write is that f of a, b, and c is equal to when a is 0, then b controls, so a and b. When a is true, then b not c or b c. And these are, of course, ands. Controls it. So there. Now, one thing we have to realize that, yes, you can use compression to get compressing truth tables to get an expression, but you have no guarantee that this expression is the minimum. Okay? As a matter of fact, you may, if you probably can reduce it further. Okay? So that's compressing the table if they are nice and they give us compression one at a time and everyone is with respect to minimum. Now, let's say someone comes and say, instead of telling you to compress it this way, they will give you this truth table exactly as we have it here, but then they tell us compress it only, compress with respect to a. That's a bit of a problem. So typically when you want to do this, the very first thing you have to do, the very first step, if somebody asks you to do it such that a is not your least significant, then you have to redraw this truth table such that a is your minimum. So if I redraw this one, I'm going to have b, c, a. And then I have to redraw the truth table. Okay. Now, the function value has to stay the same as it was before, but now what I have to do, I have to go back here. So, okay, if it's 0, 0, then this is the row that I get the data from, so that's function 0. If it's 0, 0, 1, this is the value I want, because it's really in this table, it would have been 1, 0, 0, so it's 0. And then on and on. So 1, 1, 0 would have been a 5 here, so that would be a 1. And then 1, 0, 0 would have been 0, 1, 0, which is a 1. And 1, 0, 1 would have been a 1, 1, 0, which is 6. And then a 1, 1, 0 would have been a 3. Okay. And then The last one is all the same. It really doesn't would have been the same. So assuming I copied that correctly, you notice that you have to go back and rewrite. Now, once we are here and we've done this, then the process becomes very similar to what we've done before. A is the least significant bit. You can group of twos. You can group them in twos and go on. So the compression, so the truth table compressed with respect to A would end up looking, we will have B and C on the input side and the function on this side, where 0, 0, 0, 1, 1, 0, 1, 1, and then we get these two. So okay, if B and C are 0, it really doesn't matter what A is. Then we go over here, it says, if that doesn't, A doesn't matter, so that's a 1. And at once, oops, what happened here? Did I miss something? It looks like I missed one here. So go ahead and add that and work with that as well. But the process, as you can see, is very similar to that. You notice that I missed 0, 1, 0. But that's, you can go ahead and add that. But the process would be exactly the same. You group them in groups of 2, and then you go ahead and rewrite them here. So let's see if I can kind of clean this up and get back the correct one. So in here, let's get the right color. I forgot this was 0, 0, 1, and then would have been 0, 1, 0, and then 0, 1, 1, which means the grouping would have been this group 1. So 0, 1 would have been 1, 0, 0, and that's a 0 value. 0, 1, 0 is right. 0, 1, 1 I think was the one we were missing, which would have been 1, 1, 0, and that would have been a 1. And then 0, 1, 0 would have been a 4, which is again 0. So this is our second grouping. And then the third grouping would have been 0, 1, 0, 3, I'm sorry, 2, which is a 1. And this would have been 1, this would go to the other side, 1, 1, 0, which would have been 1. And then this is a 3, 0, 1, 1, which is a 1, and that's perfect. So we got it. All right. So let's go over here. We this one, regardless of what A is, it's a 0. Regardless, okay, they look like whatever A is, F is as well. So in this case, it would be simply A. And then for this one, doesn't matter what A is, the output is 1. And finally, for the last one, you see is the inverse, so it's going to be A naught. So this was a compression. So the only extra step you had to rearrange it. And of course, as you saw, I made a mistake. So you got to be really careful to write all the possible combinations and make sure you copy the right row down here, because they're not a one-to-one correspondent. Okay, that brings us to the end of compressing truth tables.